Hello and Assalamualaikum. Today I will present about our mini project. Our project is about synchronous counter, and this will we go for the hello. This is me Muhammad Syami bin Saifuddin, and this my group member Muhammad Akmal Hakim bin Zulkifli. Okay, today we will talk about synchronous counter. Synchronous counter. The cumulative flip-flop delay seen in ripple counter is removed with synchronous counter. The clock signal for each flip-flop is the same on the next clock transition. Each gate select will when each more significant bit flip-flop change state toggle. Setting the J and K input of JK flip-flop for instance can provide such as control. We say in a paragraph enable. The addition of common clock will synchronize data transfer and cause the all flip-flop to change the state at the same time because of this control. The transition of the individual flip-flop are synchronized to master clock signal, which is important feature of a synchronous counter. JK flip-flop. Due to enabling controlling feature of the J and K input, the JK flip-flop are commonly used in synchronous counter. The J and K inputs can be generated in one of two ways. It's worth noting that the data for J and K input is generated in parallel. As a result, the counter is not as a synchronous parallel counter. The number of input each AND gate increase linearly with the number of stages in the parallel scheme. For this additional cost, the fastest possible synchronous counting circuit is obtained. Introduction project. The project background about our mini project background will display this output. Start with D and with C. So in the between them is 5, 7, A, 2 and 3. Then initially we go back, run back to D. We using JK flip-flop for organize the arrangement as above. The project we using multi-sim software to implement the counter. The IC that we use for counter is IC 7473 and some gates such as gate N7408 and gate OR 7432 and 4 output light emitting diode LED and using a 7 segment as a display for the number. Next for the truth table, Muhammad Akmal Hakim will represent about this.
Hi, I'm Muhammad Akmal Hakim. So this is our truth table that we construct. In this side is our counter that we choose for this project. Present state is a binary number for the counter. Next state represents the next number of counter. After D is number 5. J and K is the input for the flip-flop in this project. We using a 4-bit synchronous counter. The first one is J4 and K4. We take a first number from present and the next state. Based on the formula, 1 to 0 is a J4 don't K4 is 1. And now for the second step is 1 to 1 is JK J3 don't K3 is 0. Third step is 0 to 0 J2 0 K2 don't K. And the last step for the first row is 1 to 1 J1 don't K1 0. Do the same step for all the counter. When we finish construct the truth table, we're using K-map to simplify the input for J, K and Q in the flip-flop. So this is our K-map that we construct. Using this K-map, we design a circuit for our mini project. And this is our circuit after using a K-map. And now I'm going to show a simulation of our abnormal counter. This is our circuit that we construct based on K-map. We are using a 4-bit asynchronous counter for this project. All clock for the flip-flop is connected to the switch for synchronous counter. As you can see, the first counter is D. After the second pulse, it changes to 5, and the next pulse, it changes to 7. After all 7 states, it goes back to the first counter, which is D. So this is our presentation in this video. Thank you for watching.